Hi, so this is a quick session on understanding what we mean by the axis of symmetry. And to understand this, you have to make sure you understand this keyword symmetry. And basically, symmetry means if something is symmetrical, just say I drew a circle. If I cut that circle in half, both sides are exactly the same. Both sides are mirror images of each other. And that's what we mean by symmetry. Now, a parabola is also a shape that is symmetrical because if I cut it in half this way, you can see both sides are mirror images of each other. They're the same. And we can fold this in half and there won't be anything left over. So that's what we mean by symmetry. Now, axis, now remember we have a y-axis and we have an x-axis, okay? So that's referring to sort of like a line. And it's not referring specifically to the y-axis in this example, but I'm just saying axis refers to a line, in this case, cutting through a parabola exactly halfway to make it and to show that axis of symmetry, to show where it is symmetrical. Because if we draw another parabola, if I cut the parabola this way, okay, are both sides going to be exactly the same? No, they're not. If I fold it, this is a curved part, whereas this here is just quite straight, never actually ends. If we try and cut it again, maybe this way, is that an axis of symmetry? Will that line cut the parabola exactly in half where both sides are the same? You can clearly see it won't. Once again, it's curvy here and straight there. So with a parabola, there is only one line that we can use to cut it in half, and it's this vertical line here. Now, if we look at this line, where is it passing through? What's an important point it is passing through? Well, you can see it's passing through the turning point. Okay, and that's very important to know that the turning point is actually the point where it's halfway, and where if we drew a line passing through the turning point, it will give us, just say we have to cut this out, we can cut it exactly in half. And both sides are the same. They're symmetrical. So if we look at a parabola on a graph, and if the question asks us, draw the axis of symmetry. So the first thing we'll do is locate the turning point, and we can see the turning point is right here. That's our first step. And now to draw the axis of symmetry, we simply get a line. It's usually a dotted line, and make sure it passes through the turning point, and there is our axis of symmetry. And we can write that axis of symmetry. Okay? And that is a line that cuts our parabola in half and both sides are symmetrical. And that's it. Now, with the axis of symmetry, you can actually write an equation for this. So let's just recap on straight lines and drawing straight lines. Now, if you remember with linear graphs, if I asked you to do, so we've got equation 1 and equation 2, and we know when we have these kinds of equations where y, in this case, for the first one, is 2 and only 2, if I asked you to draw that, you would do your y and x-axis, and this is saying y is only 2. So we go to positive 2 on the y-axis, there it is, and our line will pass through 2, and that's it. And we know this gradient of this straight line is 0. Okay? And that's all we have to do. To draw this equation here for question 2, x can only be 5. X is equal to 5. So we'll draw our graph, our y and x-axis. And now locate positive 5 on the x-axis, because x can only be 5. And this is where we have our vertical line, or the undefined line. And we can draw this because we know x is only equal to 5. Now, with the second equation, x is equal to 5, this is going to be used and seen when it comes to the axis of symmetry. So if we just go back, okay, see how we've got this vertical line here? That line can have an equation. X can equal something. What will x equal for this one? Well, it's passing through when x is positive 1. So the equation for the axis of symmetry, we would say x is equal to 1, okay? Because this is a vertical line, and we know how to draw this vertical line from our chapter in term 1, and it passes through exactly halfway on this parabola. And this x value is actually the x value of the turning point. This is our turning point value for x. So if I had to write the turning point, I would say x is positive 1. And to estimate, if I go to my y-axis for that turning point, I could say it's approximately 1.6, just say. We haven't found it yet, but we can clearly see the x value of our turning point is 1, and that is our axis of symmetry. So all you have to do to write the axis of symmetry is to write it as an equation, x equals something. And the value that it is the value of the turning point, the x value of the turning point. So let's try some more questions. Now let's look at this parabola over here. The question is asking us to locate the axis of symmetry, or to write down the axis of symmetry. Now, I know it's sort of done for us, but let's just have a look and see. So we've got our parabola here, and our first step to locate the axis of symmetry, first locate your turning point. Okay, and you can see how this purple line is the axis of symmetry, and it cuts through the parabola exactly in half. And now all we have to do is now write the equation of this straight line. And the equation of the straight line, well, we've got our origin. So we've got 1 and x is 1. That means x is 2. So the axis of symmetry for this parabola is when x is equal to 2. And that's all you have to do. And we knew x was 2 because all we had to do was go to our turning point, look at the x value of our turning point, and write it as an equation. And we know this equation, if we draw it, gives us a vertical line. And that's it. So hopefully you understand the axis of symmetry a bit better. And just remember, all you have to do is locate the turning point, locate the x value, and write it as an equation. Thank you.